The dairy sector constantly seeks innovative feeding strategies to enhance productivity, maintain animal health, and ensure sustainability. One such promising approach is feeding Fermented Total Mixed Ration, TMR, a carefully blended and fermented mixture of forages, concentrates, and essential additives. Fermented TMR is gaining popularity globally due to its numerous advantages, including enhanced nutrient preservation, improved digestibility, and stable feed quality, which collectively contribute to better milk production. Let us explore the benefits, preparation methods, and practical applications of fermented TMR, especially in tropical climates. Feeding fermented TMR provides a range of benefits that positively impact the productivity and well-being of dairy cattle. One of its key advantages is its ability to maintain feed quality over time. The fermentation process preserves nutrients by creating an anaerobic environment, preventing spoilage and oxidation. This ensures that cows receive high-quality feed throughout the year, even in challenging weather conditions. Another significant benefit is the enhancement of feed palatability. The fermentation process produces pleasant aromas and flavors, encouraging cattle to consume more feed. This often translates into higher milk yields with improved fat and protein content. Furthermore, fermented TMR promotes better digestion due to the partial breakdown of fibers during fermentation, making the nutrients more bioavailable to dairy cattle. Fermentation also introduces beneficial microbes, such as lactic acid bacteria, which contribute to improved gut health and more efficient rumen fermentation. By stabilizing rumen conditions, cattle experience fewer digestive issues, ensuring consistent milk production. Additionally, fermented TMR minimizes feed wastage and labor costs as it can be prepared and stored in bulk for extended periods. Preparing fermented TMR requires careful selection and blending of ingredients, followed by a controlled fermentation process. The first step is choosing appropriate feed components, which typically include forages, concentrates, byproducts, and essential additives. Forages such as maize silage, Napier grass, and sugarcane tops are ideal, while concentrates may include maize meal, rice bran, and oil cakes. Molasses is often added as a fermentable sugar source to facilitate microbial activity. Once the ingredients are selected, they are chopped into smaller pieces, 2 centimeters to 4 centimeters, to ensure uniform mixing. The forage and concentrate components are combined in balanced proportions, usually a 40% to 60% ratio favoring forage. Inoculants containing lactic acid bacteria are sometimes added to accelerate the fermentation process. The mixture is then packed tightly into airtight containers such as silos, plastic drums, or heavy-duty bags. Removing air is crucial to create the anaerobic conditions required for fermentation. The sealed mixture is allowed to ferment for 2 to 4 weeks. During this period, the pH of the feed drops to below 4.5, indicating successful fermentation. Once fermented, the TMR can be fed directly to dairy cattle. Several countries have successfully integrated fermented TMR into their dairy farming systems. Japan is a pioneer in the development and use of fermented TMR, with extensive research backing its efficacy. South Korea, the United States, Canada, and European countries such as Germany and the Netherlands have also widely adopted this feeding strategy. In these regions, fermented TMR has become a key component of modern dairy production, particularly in large-scale farms. Emerging dairy industries in tropical and subtropical countries, including India, Thailand, and parts of Africa, are increasingly recognizing the benefits of fermented TMR, especially in addressing feed preservation challenges. Tropical regions offer a variety of feed resources that can be utilized in fermented TMR formulations. Common forages include Napier grass, Brachiaria, and Guinea grass. Agricultural residues such as paddy straw, corn stover, and sugarcane tops are valuable sources of roughage. Concentrates like rice bran, coconut oil cake, and cassava chips are readily available and cost-effective. Additionally, byproducts from food processing industries, such as brewers' grain and molasses, can be incorporated to enhance fermentation and nutritional content. Locally produced oilseed cakes, including coconut, sesame, and peanut cakes, also contribute to a balanced feed. Despite its advantages, adopting fermented TMR in tropical regions presents challenges, including high ambient temperatures that can cause spoilage. Moisture control is also critical, as improper moisture levels can hinder effective fermentation. Limited access to high-quality microbial inoculants and airtight storage facilities further complicate the process. To overcome these challenges, farmers are encouraged to ensure proper moisture levels, 50% to 60%, use molasses as a fermentable substrate, and invest in appropriate storage solutions. Training programs on preparation techniques and fermentation management can also play a vital role in promoting the successful adoption of fermented TMR. Fermented TMR is a game changer for dairy farming, offering a sustainable solution to feed preservation, improved animal health, and enhanced milk production. Its potential is particularly significant in tropical regions, where feed spoilage and seasonal fluctuations pose challenges to livestock management. By adopting this innovative feeding strategy, dairy farmers can achieve greater efficiency, sustainability, and profitability while ensuring the health and productivity of their cattle. With proper knowledge and techniques, fermented TMR can become a cornerstone of modern dairy farming practices in both developed and developing regions.